Hello everyone and welcome to today's video where we will talk about general navigation and more specifically we'll have some questions with examples regarding the Lambert conformal chart and calculating conversion angles and some other questions of this type, and I'm sure this will be useful if you're preparing for the exams or just trying to revise Gen GNav as a whole. So let's jump into question number one. Without any further ado, I'll try to go in depth and also show you some graphics that will support the study. So on the Lambert conformal chart with standard parallels at 40 north and 55 degrees north, the initial track angle of an airway from point A to Aalborg is 68 degrees true. What will be the track of arrival at Aalborg? So of course, as you probably already know, if you simply depart from a place and follow a certain heading, your track will begin to change because your track is measured as an angle from the parallels. So of course, the parallels will change because the Earth is a globe if you simply follow one simple heading. And there is actually an accident from that some time ago that happened to Korean Airways flight 007 that I actually wanted to show you. And this is what happened. Essentially, there was a lot of factors that came into play here. However, if you can see, the crew simply followed one simple track instead of following the Great Circle track by following simply a heading. And as you can see, the actual path that happened was vastly different from the intended path, which the intended was the Great Circle track. They went off course as much as multiple hundreds of miles, and as you can see, actually the USSR in the past has confused them with a military jet and shot them down, sadly. However, this is just to show you that these things are vastly important. And now going back to how to actually calculate it, of course, the standard parallels are very important here, and they are given for a reason. The reason for them there is that we can calculate the conversion angle by getting the parallel of origin, which is always in between of two standard parallels. So of course here, to calculate the convergence, we simply will multiply the change of longitude, which is east-west, times the sine of parallel of origin. So of course the change of longitude here will be 25 degrees from 15 west to 10 east, times the sine of parallel of origin, so the mean between 40 and 55, and that is 47.5. So if you do this correctly, you should come to an answer which is 18.425 degrees. This is your conversion angle. Now the question is whether it is increasing or decreasing, and there is a great thing for you to see. And of course, this is referring to the standard parallels and the parallel of origin. As you can see, the one is in the middle. And now that we know that our conversion angle is 18 degrees, now the question is whether to add it or subtract it. There is a great mnemonic which goes di, di, or dd. So simply, if you're going eastbound in the northern hemisphere, you increase. And if you go westbound, you decrease your track of arrival. So in this case, we will have 68 plus 18. This gives us roughly 86 degrees true, and this will be the correct answer for this question. For question number 2, during a visual flight, a useful method for a pilot to resolve any uncertainty in the aircraft's position is to maintain visual contact with the ground. And so remember that generally speaking, when flying VFR, meaning a visual flight, what you'll do, you'll usually use dead reckoning skills. So you'll set your aircraft on a heading and start a timer in order to follow a certain track. Now, it is very important that once you're navigating, you will be using the principle of map to ground, meaning first you look at the map and then you try to spot the features, which will help you to time your aircraft better, to time your turns, and to dead reckon well. And however, if you get lost, if you are uncertain of your position, this will be reversed. Now you will use a principle of ground to map. So first you'll try to spot some visual features on the ground and then put them back on the map. And this is surprisingly difficult because a lot of features are very hard to identify because there can be an abundance of roads or lakes. This is why it is very, very important to always try to find very distinct features such as coastlines, railways, or big lakes. Sometimes big cities can help. However, it can be more difficult than you imagine to spot and well identify a city. So of course, coastlines, big highways, rivers or railways are always going to be your best friend. And also, there is a great principle that I wanted to remind you of, which is, the 5 C's of aviation. So this is what happens if you get lost. Essentially, it's a cool mnemonic that you can use to remember what to do if you are uncertain of your position. Always first confess to yourself and then the ATC, circle or climb in order to not breach any obstacle clearance. So you circle in order not to lose your position. This is also why the other answers of flying reverse heading are not particularly correct, because if you were following a wrong heading, flying back in reverse sometimes might be put you even in a bigger distress, or you might get lost even more. Then you conserve the fuel, so you fly at VMP or VMD depending on your aircraft, communicate with ATC, and of course comply with the instructions or the vectors given. For the question number 3, so determine the necessary rate of climb for the given situation. An aircraft is cruising at flight level 120 and needs to cross a mountain ridge at a minimum safe altitude of 18,500 AMSL. So this is a classic question again when it comes to calculating rates of climb. And the biggest trick that the examiners are trying to play on you here is you adding altitudes with flight levels and vice versa, or subtracting them. So essentially remember that if you have an altitude with a reference datum of standard and the QNH, adding them or calculating them together will be exactly the same as adding apples to oranges, as adding kilograms to tons. You cannot do this. You need a common datum. In this case, with the QNH given, you can very simply convert the flight level at 120 into an altitude. All you need to do is just subtract 13 hectopascals times 30, which is the standard lapse rate, and this will give us essentially what you need to do. If you do this math correctly, you should get an altitude of 11,610 feet. This is your altitude, which is expressed in flight level 120. Now, all you need to do is simply divide it by the time it takes you to cover 60 nautical miles. Here we have TAS and tail width of 25, so the ground speed is 145, meaning the time will be 24.8 minutes. And always remember to use minutes for these examples. Now, if you do the math again, so you divide your altitude needed to cover by the time it takes you to go there, you will get that you need to climb with a rate of 280 feet in order to cross that obstacle. For these questions, also remember that sometimes the wind might not be given as straightforward as here. Sometimes you will be given winds at different altitudes. Remember that for climb, you always take the wind at 2/3 of the altitude, because as you climb, the aircraft's engines are less efficient higher up, so you will start climbing slower. And on descent, it doesn't really matter that much, so you take the wind at halfway. For question number 4, 2 places on the parallel of 47 south lie 757.8 kilometers apart. Calculate the difference in longitude. So this is a classic question that will ask us about the departure, and these questions actually will come in abundance during your GNAV exams. For these type of questions, remember to always change your kilometers into nautical miles, because this is what you simply need to calculate. For departure, you always use the cosine rather than sine, as we used previously. So remember that your departure, so the distance in nautical miles, will be the change of longitude or difference in longitude times the cosine. Now, if you simply transpose the equation for you to get the difference in longitude, you'll get the answer of approximately 10 degrees or 600 minutes. Remember that the difference in longitude has to always be in minutes, and 1 degree is equal to 60 minutes. So this is a very important thing to also remember for the exams, to have the right units. For question number 5, an aircraft departs London Heathrow to New York. Calculate arc-to-arc time between London Heathrow and JFK. So we have quite a few different times that you need to remember for your GNAV exams. You'll have the local mean time, you'll have the standard time, the Greenwich time or the GMT, the UTC, which is the coordinated universal time, and the sunrise, sunset, and the civil twilights. So of course, The arc-to-arc time will be simply your time that is referenced to the longitude, east or west, similarly to the local mean times. For the arc-to-arc times, all you need to remember is that 15 degrees are equal to 1 hour, or simply 4 degrees are equal to 1 minute. And also for these questions, remember that Greenwich, the GMT, will pretty much be equal to UTC. The only difference between the two is that UTC is an atomic clock time, and GMT is actually the local mean time at the Greenwich in England. The standard times are based politically, so I can show you a map of the world. This is the map divided into standard times. They roughly follow the local mean times, however, they are politically influenced, so they will not always be exactly the same. And there is one last important consideration, which is the international date line that I wanted to show you. As you can see, international date line is also politically divided in the world. So this, of course, is artificial, doesn't exist. However, it's something that we need to remember. And here in this little hammer is actually a beautiful town of Kiribati. So as a bonus, you can actually know this as a little fun fact that Kiribati is right there, and Kiribati every year will enter the New Year's first. However, going back here, so all you need to do in order to know the arc-to-arc time difference between London Heathrow and JFK is to know the difference in longitude. So here we have 63 degrees 46 minutes west and 27 minutes west. Simply subtract one from another, and then you can divide it by 15 to get the hours, or by 4 to get the minutes. And what you will get is 4 hours and 53 minutes will be the arc-to-arc time difference between the two cities. And for the last question, so question number 6, what is the approximate value of Earth convergence between points A and points B? So again, this is a similar question to what we've seen at the beginning of this video. So the only difference for these type of questions then to compare to the Lambert charts is that if the Lambert chart is not directly stated, we will simply take the mean latitude between these that are given here. So there are no parallels of origin, there are no standard parallels. We will simply take the mean one. So here mean between 60.58 and 50.58. So it will be right in the middle, which is 55 degrees and 58 minutes. Then we take the sine of this and we multiply this by the change in longitude, which will be about 25 degrees and 23 minutes. If you make the calculations, so 25 degrees, 23 minutes times sine of 55 degrees, 58 minutes, you will get the answer of 21 degrees and 2 minutes approximately. And this will be the correct answer here. Exactly the same question as we saw at the beginning of the video. However, here we are not being told that this is a Lambert conformal chart, which essentially means that we need to disregard the standard parallels and simply take the mean between the latitudes. This will be everything for today. Thank you so much for joining us, joining me. And if you wish to see more questions like this, then of course, follow Airhead and get a subscription so you can practice these questions in your own free time and get all the explanations in one place. Have a fantastic day. Wish you all the best in the exams, and I hope to see you in the next video. Bye-bye.